Hello everyone, welcome back. So in this video we are going to understand today contest problem from the delete contest series. So the question number is 1948. Delete duplicate folders in the system. The question is saying that due to bug there are many duplicate folders in the file system. So you are given a 2D array paths where path at I is an array representing a absolute path to the ith folder in the system. For example, 1 2 3 represents the path 1 2 3. Two folders you can see not necessary on the same level that are identical if they contain the same non-empty set of identical subfolders underlying the subfolders structure. The folders do not need to be at the root level to the identical. If two or more folders are identical, then mark the folder as well as their subfolders. For example, folder we have given /a/b in the file system file structure below are identical. They are as well their subfolders should all be marked /a/x, like that we have given these things, right? Let me go a little up. For example, these are the paths we have given. However, if the file structure also include the path /b/w, then /a and /b would not be identical. Note that /a/x and /b/x would still be considered identical even with us added subfolder. Okay, added folder. All the identical folder and their subfolders have been marked. The file system will delete all of them. So the file system only runs the deletion once. So any folders that are become identical after the initial deletion are not deleted. So return the 2D array that is called answer containing the paths of the remaining folder. After deleting all the marked folder, the path may be returned in any order. Okay, so this example we have given is example 1, like this we have given. So these are the paths we have given, and the D itself and DA we have here, means the file structure is as shown here, we can say. And it is saying that folder A, right, and folder C and their subfolders are marked to be deleted, right, because they both contain an empty folder named B. Okay, so after understanding the questions, we can say that this question is based on what you called the Trie DFS and subtree serialization, right? We can say that because the question is given what we have given here. The question given a list of what you call path, right? That is called folders, right? Path folder paths, and some folders are identical structure, right, as you can see here in this example. So even though they are in a different places, your task is to delete or detect all the first you will detect it and then you will delete, right, all the folders that are in the duplicates, right, meaning they have the same subfolder and the structure, right? But here is a twist that you delete the folder and all of its children, right? As you can see in this screen, right, we have given a paths, we have given A, C, D, like this we have given, right, from here to here, you can say. But its children and itself, right, we have to delete it, right, because these are necessary to delete, right, because A and if you see here, right, A and C both have a single folder, name is B inside it, right? So exact same structure we have here, can we say that? So they are deleted. The result is just /D/A, and that is why it is coming D or /D/A. Understand? So we will use try to build the folder structure, and then we will perform DFS to serialize each folder folders as a subtree, right? Folder subtree, you can say. Basically, we are turning each subtree into a string. So if two folders produce the same string, they are duplicate, right? So for this, what we should do, we should build tree from folder path, we can say, from this folder path, and we will build this tree, we can say, using the trie, and we'll do what? We'll serialize each of this path. We'll do the serialization, which, and then we'll detect the duplicates using the hasmap, and then we'll mark all their children, right, so that we can delete easily, right? We'll collect all the non-detected deleted folders like this. That's pretty elegant, right? So can we say that, like, let's suppose we'll create a trie class. So trie class should have, what are the methods should have? It should have a serialization method, should have the mark delete method, like for the recursive logic, right? And the DFS method to calculate the final output. So we'll use hasmap to track the serialization, right? A serialized subtree, right? And if the structure appears more than once, we'll delete all of them, right? And the remaining will print out. So let's go to see the slide so you will understand better. So what are the things we have given? We have given the list of folders, right? We have given a list of folders path that is called in a file system, right? So some folders are exact copy of each other, meaning they have the same structure and the subfolders. So what is our job? Our job is to delete all the folders that are duplicate along their subfolder. So for example, if we'll take this example, we have input, let's suppose call these paths. What are the paths we have? A, C, D, A, B, C, D, like this we have given, right? So if we will represent this path in the file system, let's suppose this is your root, right? And the root have A, then we have B, C, we have B, D, we have A. Means these are the folders we have given, and these we have given as a subfolder, right? So what we are trying to say, as we can see here, right? So this folder we have what? A, C, D, as you can see here, right? Then you have B, B and A, B, B and A subfolder, right? Means this represents the folder slash A slash B slash C slash D and slash B, right? And slash D slash A, right? So let's understand slash A and slash B and slash C and slash B means slash A slash B slash C slash B. These two are having the common, right? B means they have exactly the same, both just have a single B folder structure inside this. It means folder A and folder C are duplicate, right? So we should delete both of them, right? So everything under them, right? How this is how the viruses do this, means it will copy all the files, only it will change the parent name, right? So it will keep increasing on your system. Storage will get increased with the resources, and once it is full, it will hang your system, it will do slow, right? That is why Windows system we use to keep deleting the unnecessary things, and also we should have antivirus like that we are doing it. That is a different thing, just I'm saying to relate this. So the resulting folder left is what? Only slash A slash D, because this is left and this subfolder left. So for this we'll set slash D slash A, but for this slash D, right? Because D and slash A don't have any duplicates elsewhere rather than here. So what is the rule we found here? Means two folders are duplicates if and only if they have the same subfolder, correct? The subfolder structure are also same, right? So it doesn't matter where the folder are, and if the structure is identical, we must delete all of them and their children. What not to do? We don't just delete the root folders, we also delete everything inside them, all children, all grandchildren. So our output is slash D, for the slash D is double quote AD and slash D slash A, we will put like this. Okay. So if you talk about the intuition, so first of all, think about the file system as a tree, because there are lot of folders and each folder will treat as a node, right? So the full folder structure is become like a forest, a collection of folder tree, right? We can say that. So it's a complete nesty and it become a file system, right? So you understand everything here, right? Because this is in the regular life we are using on the laptop. So what is our key insights means two folders are identical if their entire subtree structure, we call children, grandchildren, is same. So if we'll say let's serialize, right? We'll serialize each folder substructure into string, means we'll convert the given thing into string, so that we'll do the string checking. If two folders have the same string, right, once we will convert into string, it means we can check the value. If both having same, means it's duplicate, and then we'll mark those folders and their children for deletion, right? So what we will do, right, to implement the code, very first we'll build the the folder tree. So it represents folder using the trie, that is called prefix, and each folder is a node. So each input path we can call A, B and C, means it creates slash A slash B slash C. Can we say that? And if this is an example, so it becomes like the root itself, and then we'll say A, X will go to Y, like this structure will perform for this input. So once we will do the serialization, right, first we have created what? We will build the trie. So once you will build the trie, means we want to represent the folder structure into trie, a prefix tree we can say, right? So we will perform this, right? Then we will serialize the subtree, means we will create a unique string representation of each folder's subtree structure. For example, let's call this is we have given. It means X is Y and G are children, right? Means X is a, let's suppose, called parent. It has two children, Y and G, right? So Y and G are children. So if we'll do the serialization, we can say serialize folder as A as X, Y and Z, and X, Y and Z, like this we will say that for A and B. So if two folders have the same serialization, they are duplicate, right? So you have to perform like that. Let's suppose we'll want to detect the duplicate, right? So we'll use map, where we will have the key and value will have the list of node to group the serialization structure. So very first, if the serializations appear more than once, we'll mark all the folder for deletion. So further we'll delete the marked one. Okay, for each duplicate serialization we will iterate and we'll mark the folder and a subfolder as a deleted, right? And then we'll collect the remaining one and we'll reverse the tree again using the DFS. So this step we will keep repeating until we'll find all the valid path into the result. Okay, so what we will do, the task we have to implement very first to build the file system tree, then we'll do the serialization each step, and then we'll track the duplicates and we'll mark the duplicate for the deletion, and remaining will be get collected for remaining paths, right? So very first we'll use a trie, then we'll use DFS, then we'll use map, and then we'll use recursive. We'll keep going that and we'll mark it, and further we'll do DFS traversal. So what is the data structure we will use? So trie, we have trie as a tree to store the folder hierarchy. Then we'll use map, where we have string and list of trie. So we'll store the serialized subtree and we'll detect the duplicate value. And this is our DFS to serialize the thing. So let's understand the code and we'll understand how we are going to implement it. So very first, what we will do, we'll create a trie, right? To create the trie, we have the name we'll create, and we'll create a children map. and we'll say should we delete it or not, right? So this will treat as a trie, right? And this will be our submap tree, right? For that we'll create a string, and this will be our list of tries, right? Like a node, as you can, a kind of node we can say, that will contain the name and its children, and this will be your subtree map, right? So all the subtree means there will be the key, and this key will contains a list of what you call children, right? Name. Now we will have we'll create a duplicate folder where we will build first try. How we are going to build, you know, first of all we'll initialize this root, and for all the paths we'll get one by one path, right? And we'll say this is our current try, right? And then we'll get the folders one by one from the path, and we'll check on the current dot children, and we'll check compute if absent. If it is not on the map, we'll just put it on the map, right? So we'll say treat as a new folder, like this is this part, we can say that, right? This part. So this part will say treat as a what we call as a new node, and we'll assign the node as a node dot name is equal to k and return the node. Okay, then we'll do the serialization. I hope you understand the compute function. This is a kind of put method. If it is not there, just we'll add there. Then we will do serialization. We'll convert the data and we'll collect them, and we'll map and we'll mark the duplicate node. We'll traverse on the node list and we'll mark this node as a deleted. Then we'll collect all the nodes in the list, right? So for that we have to traverse the DFS over the result from the root, and then we'll return result. So we have this serialization method, and this is our mark method, and this is our DFS method. Let me know if you have any doubt in this video. Okay, thank you guys, thank you for watching this video, and keep trying hard so you can understand everything, all the logic. Still, if you have any doubt in any of these method or any other topic missing here, let me know in the comment section. Okay, thank you for watching this video. Let me know in the comment section. Thank you. I'll see you in the next one.